So we've covered why there are different optimal temperatures for different microbes. Primarily, it's the plasma membrane and enzymatic activity. So now let's talk about why there are optimum pHs for different microbes. Both high and low acidity can be physically damaging to cell parts because acids and bases both are reactive and so can break down important molecules in the cell. Both acids and bases can also denature enzymes by interfering with the way amino acids interact with each other in that long amino acid chain that makes a protein. So microbes that like it neutral are called neutrophiles. Microbes that like it acidic are called acidophiles. Microbes that like it basic or alkaline are called acyl-ophiles. Okay? And again, these are not the only curves out there. Every single species of microbe, it's going to have its own unique curve that represents its optimum pH. The optimum pH is where the microbe grows the best, and its pH range, which is the possible pHs it can grow inside. Okay, so this is the range, this is the optimum. Same for temperature. There's a temperature range and a temperature optimum, and it's unique for every species of microbe. All right, so let me remind you what pH is. So pH is a measure of acidity, and pH lies on a scale from 0 to 14. So what is acidity exactly? Well, acidity is the measure of of hydrogen ions or hydronium ions floating around in solution. So a hydrogen ion hydrogens all have one proton in the center, and that can be matched with a single electron in orbit, which would make it a neutral charge. One proton, one electron, one positive charge, one negative charge. They cancel each other out. A hydronium ion is a hydrogen ion that has lost its electron, leaving it with only the positive charge of the proton, unbalanced by a negative charge from an electron. Okay, so hydronium ions are pH is a measure of hydronium ions in solutions. The more acidic, the more hydronium ions there are. Okay, so acids have a lot of hydronium ions. Bases have very, very few hydronium ions. Okay, now this is counterintuitive because the more acidic it is, the lower the pH, right? And that's a little bit, that has to do with the math that coming up with the scale. And the reason is when you're measuring the number of hydronium ions in a liter of water, so it's when you have it's 10 to the negative exponent. So you don't have to remember this. I'm just going to explain it real quick for those who like the math. So if you have a pH of 1, that means you have 10 to the negative 1, which is, so 10 to the negative 1 moles of hydronium ions per liter. Okay, 10 to the negative 1 moles of hydronium ion per liter. That's going to be 0.1, right? That's 0.1 moles of hydronium ion per liter. A pH of something more alkaline, like a pH of 14, is going to be 10 to the negative 14th moles of hydronium ion per liter, which is like 0.0000000, like 13 zeros and a 1 hydronium ions per liter, moles of hydronium ions per liter. So 10 to the negative 14th is a smaller number than 10 to the negative 1. So that's why, 10 to the negative 1 is more hydronium ions, 10 to the negative 14th is fewer hydronium ions, and that's why the pH scale seems backwards, because the number is actually representing the negative exponent, and negative 14 is smaller than negative 1. Okay, but if you prefer not to think of the math, just think 10 to the negative 1, or if you don't prefer not to think of the math, just think, it's backwards from what you would normally expect. So the lower the pH, the more hydronium ions and the more acidic. Okay, so here's a pH scale. So increased acidity is down here. This is more hydronium ions. Acids, and here's some examples of just everyday products or everyday items that have different pHs. So battery acid is about as acidic as it gets. Right? Lemon juice, vinegar, that's pretty acidic. Tomato juice, kind of acidic, right? And here's neutral. So acids are damaging because hydronium ions are reactive. They will steal electrons from other molecules and break molecular bonds. When hydronium ions are low, That's usually balanced or by an increase in hydroxyl ions, which is OH minus, right? So it's not the absence of hydronium ions that's damaging about bases, it's the increase in hydroxyl ions. So bases or alkalines are damaging because hydroxyl ions are common when hydronium ions are absent, and hydroxyl ions are reactive and can break up many kinds of biological molecules as well. Okay, OH minus is reactive, H plus is reactive. They're both reactive. Okay. So different microbes are going to be adapted to certain pH conditions. They're built to exist under a certain concentration of hydrogen ions or hydroxyl ions. And so when the concentration changes, the molecules and enzymes start falling apart. So this is, again, mostly about enzyme denaturation. So for us, our enzymes are structured to retain their integrity at a neutral pH. So if they encounter a really acid pH or a really alkaline pH, that's going to disrupt those proteins or those enzymes, and they'll start to denature and they'll fall apart. Now, vaginal bacteria create and prefer a pH of 4. So one of their metabolic byproducts is lactic acid. These are the same bacteria we talked about in the metabolism chapter that make yogurt. So the vaginal microbiome is mostly lactobacilli species. And we talked about how lactobacilli make yogurt. They ferment, right? They ferment. They use lactic acid fermentation. That's what makes yogurt sour. That's what makes sourdough sour. So you consume these in yogurt and other probiotics, right? Well, these are the same genus of bacteria that form the vaginal microbiome. So you may have heard that the vagina is very acidic, that semen has to be alkaline to help the sperm survive the acidity of the vaginal environment. It's not the vaginal excretions that are acidic. It's the bacteria that live in the vagina that make it acidic. And that acidity is protective, right? So this acidic pH in the vaginal environment discourages other types of bacteria and fungi from colonizing because most microbes that infect the human body are going to be neutrophiles because the human body is mostly neutral. So almost everything that is trying to infect your body that wants to play house inside you is going to be a neutrophile that's going to like neutral environments like the human body. So these lactobacilli that live with women, they make the vaginal environment acidic. And that's really important because the vaginal environment is really perfect for many microbes we wouldn't want to be there. It's warm, it's moist. That's really ideal conditions for most microbes that we would not want to be living in the vaginal environment. So these lactobacilli are protective to us. They make it really, really acidic so that most other species cannot grow there or cannot grow well. Okay, so if the pH changes and the vagina that makes the vagina vulnerable to infection by pathogenic bacteria, and we call that bacterial vaginosis, or it makes the vagina vulnerable to yeast infection. So ways the pH of the vagina can be altered is blood from menstruation because blood is neutral. Semen is also neutral to basic, and so sex, unprotected sex, it's not even an STD. It's just that because semen is neutral, that raises the pH, and that it's not that semen is creating the infection. It's that it increases the chances when the acidity in the vagina is neutralized. It increases the chances that other bacteria could invade. Right. And also frequent bacterial vaginosis infections have been associated with smoking. Perhaps diet plays a role. Douching and other washing practices that seriously disturb the natural bacterial community have been shown to be associated with BV. So when women douche, they think that they're cleaning themselves. But what they're cleaning themselves are the bacteria that's protecting them from infection. So you take those you take the lactobacilli out. They're not making that acid anymore. There's no protection now against all the other bacteria that are encountered. And so after douching, after getting rid of the good bacteria that make it acidic, there's longer any protection, and that makes a woman vulnerable to bacterial vaginosis. Also antibiotics. So often when, you men may not know this, but when women take antibiotics, we're also often prescribed probiotics, and that's to replace those lactobacilli that live in the vaginal environment, because when women take antibiotics, it's often followed by yeast or other bacterial infections that invade the vagina, because the antibiotic will get rid of those protective lactobacilli, and that makes us vulnerable to getting invaded by bad bacteria. So these lactobacilli are acidophiles. and they are protecting that environment from all the pathogenic neutrophils that might set up shop there. Okay.